My name is Graphics. Now if you look at the top right corner, you see we have a problem on block and wedges. Now if you recall, a wedge is a triangular or trapezoidal object that is used to raise a load that has high magnitude by just applying a small force. And the question you see up here goes like this. It says we have two wedge A and B of mass 320 kg and 25 kg respectively are in contact, shows that the line of action of wedge A is horizontal. The coefficient of friction between the contacting faces of the wedges is 0.25. That is point number 1. Contacting faces is 0.25, while that between the wedges and the guide is 0.15, another point. The angle of wedge B is theta 1 degree, while the wedge A is 0 degree. Determine the value of theta 1 degree if the required effort to slide wedge A is 350 Newton. Now, what will be the value of theta degree if the force applied is equal to 450 Newton and the coefficient of friction between all the contacting surfaces is constant and equal to 0.2? Estimate all values of R1, R2 and R3 under this consideration. Use G as 10 meter per second square. Now we have two sections of the question, right? So let's overall deal with the first question. Before that, I want to reproduce this figure at the top right corner of the screen on my book. So let's move. We're having this, right? Now if I should go across the question again, we should write out the parameters. Now writing out the parameters that I have in this question, that will move what is in the top right corner of the screen towards the left, right? So if you view the question, it says two wedge A and B of mass 320 kg and 25 kg. So the data that I'll be having here, the data given, right? It says we have two mass. The mass of wedge A is represented using this symbol, and the mass of what? Wedge B. So we're having for wedge A is 320 kg, and for wedge B is what? Is 25 kg. Right? Now we move forward from the question. It says are in contact such that the line of action of the wedge A is horizontal. The coefficient of friction between the contacting surface. Now let me use mu1 as the coefficient of friction between the contacting surface. I'm going to write it this way, that coefficient of friction, right, between contacting surface, right, contacting surface. So don't forget about that. This is what we have here, coefficient of friction between the contacting surface is giving us 0.25. So we have mu1 to be 0.25. Don't forget this keyword. Then the other one we have mu2, that is between the wedge and the guide. It says why the angle, it says why that between the wedge and the guide is 0.15. So I said mu2 should be equal to 0.15, and between what? Wedge and guide. So I'll just put guide here just to remind us. Right? Now we move forward. It says the angle of wedge B is theta 1 degree. So we have the angle of wedge B is theta 1 degree, and that of wedge A is theta degree. Determine the value of theta 1 degree. So we have to look for what? The value of what? Theta 1 degree. Right? Now, and we are given that force that is required is 350 Newton. So P is what? 350 Newton. So that is case 1. Right? Now, after doing that, I'm going to remove what I have on the screen, and I'll be focusing on what I have here. Right? So the next thing I'm going to do is to draw the free body diagram of this. Right? Is to draw the free body diagram of this. So in drawing it, alright, FBD of the two wedge. FBD, right, of the two wedge. So we start with wedge A, wedge B. So let's see how that goes in working with what? Wedge B. So I'm going to replicate wedge B, and I'll be having something like this. Now this is what I have. I've drawn, this is for the wedge B, right? And that is what I have. Now we have three surfaces, right? If you look at between, this is wedge B, wedge A, both of them are in contact, right? Because of that reason, there will be a reaction. So I'll put my arrow here, just perpendicular to the surface. Right? I'm going to put my arrow here. Let me extend it. So arrow just perpendicular to the surface. Then between the guide also, this guide that we're having here, there's another reaction acting on it, just on the surface, and we'll have this way, and put it there, this way. So we're having another reaction arrow. Right? Now, if you notice something here, this block has a weight acting at the center. So the weight is acting straight downward this way. It's acting straight downward this way. Right? We're having straight downward. And that will be W. Right? That will be what? W. But we know W is giving us what? Mass times what? Gravity. Now the question is, which mass are we talking about? We're talking mass of what? Wedge B. So I'm going to put B here. All together. Now, if you look at this, this is the weight here that we have acting straight downward. Now this reaction here, I will say this will be my reaction 1, and this will be my reaction 2. Is that okay? Now another thing you need to understand, we say friction is a force that opposes relative motion. Now that means whenever force is coming downward, frictional force will be going upward, right? So since the force is coming downward, I'll be having a frictional force acting down upward. I'll be having something like this. So that will be my frictional force. So I'll say the frictional force is giving us F1. Frictional force is giving us mu multiplied by what? The reaction. But the key word here is this reaction we are having here is a contacting surface here between the guide, right? And on the guide, the frictional force is giving us what? Mu2. You can see mu2 is for the guide. The frictional force, and the coefficient of friction for the guide is 0.12. So if I want to now write my frictional force, right, it will be what? Mu2 multiplied by the reaction at that guide side, which is R1, and then we'll have what? R1. Is that taken? If I want to write this, I'm going to write mu2 R1. Is that taken? Coefficient of friction 2 times R1. That's how that guide comes about. Now similarly, if I am pulling this force downward, right, with our diagram that we have here, if I'm pulling this force downward, it will be moving forward, right, because of how slopey here is. It will be moving forward. So if moving forward, what happens? Friction will be going in the opposite direction. So that means at this point here, I'll be having my friction at this point here, right? So let me just put it here. So this is B, frictional force F2, right? So this is F. So what you do is, this is the contacting, this is the what? Contacting surface. We have two of them. At this point is contacting surface between wedge B and wedge A. At this point, another contact surface between A and the ground. So we're dealing with this now, right? So contacting surface here, we're going to be using what? Mu1. If I want to write the frictional force for that guy here now, it will be my F. This is F1 here. So my F2 will now give me mu1 at this surface R2. So mu1 R2. Is that taken? So we're having mu1 R2. So I'll write it here as saying my mu1 R2. You can see that I've written it mu1 R2. Now, this is what we have here. Well, there are two things that we need to put into consideration here. And the first one we're putting into consideration is that these two forces, the R2, right, and mu1 R2 are inclined. So I have to resolve them. So in resolving, what you have to do is something we call resolution of what? Forces. And that is the resolving of inclined force into vertical and horizontal components. So what I'll do is, at this point where they meet here, I'm going to draw a vertical line and an horizontal line this way. So what I want to do, I'll draw. How will you know what will happen? If I draw my line of action from this point, I see it is touching this, where they are meeting at this point here, right? I'm going to have an angle. The angle will be given as what? Will be given as theta here, right? That will be what? Theta. That will be the angle what? Theta 1. So if you look here, we're having theta here. So the angle that will be here will be what is really coming down here. So that will be theta. Is that okay? We are dealing with the theta. Now, if you notice it is inclined to what? To the vertical. And when force is inclined to the vertical, if you watch my video on resolution of force, when force is inclined to the vertical, which I will show you at the top corner of the screen, if you watch the video of resolution of force, you realize that whenever the force is inclined to the vertical line, it means that my vertical force here will give me the force cos the angle. That will be the vertical force, and the horizontal force here, are you with me, will be the force sine the angle. So this is what we should be paying attention to. Let me put it into a sign to avoid confusion. So the force is R2, cos and sine. Are we together? Now the next one here we have is this, that is inclined to the horizontal. So what I'll simply do here, I'll also resolve it, right? So what do you notice? It is like this. So if I resolve it this way and this way, this is how I'm doing it here. So when you see it, if you move it up, you notice that this inclined force is inclined and is inclined to the horizontal, right, not to the vertical. So it means that this is, we're talking about mu1 R2. So here will give me mu1 r2 sine the angle theta, right? mu1 r2 sine the angle theta is moving upward. The reason I'm putting sine is because of what is inclined to what? The horizontal. And this one will give me mu1 r2 cos theta. So this is what we have here. So also I'm putting into the bracket. This is what we are going to make use of. You might not put your own in bracket. I'm only doing this so that you'll be able to see what I'm actually working with. So now I've resolved them. So this is vertical, so I'll just use this directly. See that I'm putting them in bracket, the one I'll use directly, right? So, and I'll use the P directly. I'm going to use the arrow directly. All this one I'm putting into a bracket is what we are going to put into use. And also I'm using the P directly because it's just perpendicular here. You don't have to do this, it's just a way to enhance your understanding. And I'm going to use the weight also directly. These are what I'm going to be using. So this U1 arrow 2 is what I resolve into this and this. This arrow 2 is what I resolve into this and this. So now let us now see what we are going to be having. Now resolving these forces along vertical and as in for equilibrium to take place, right? So along y-axis, we'll say that the summation, let me put it this way, along the vertical axis or along y-axis, any of them you want to choose, we say that the summation of all the forces along the y-axis is equal to 0, where we want to consider the upward force to be positive and the downward force to be what? Negative, right? So the upward force should be positive, downward force should be negative. So let's see. If you look at this here, it is facing up. So you say mu1 r2 sine theta. We call it here mu1, right? And write it out. mu1 r2 sine theta, right? If you look at this, it's also facing up. We have plus r2 cos theta, that's cos theta, right? Facing up. Now what else again? This is also facing up, that is mu 2 r1. So plus mu 2 r1, right? Now the other one is facing down in form of P. P is facing down, so it's negative. We have minus P. And the weight W is facing down, so I will not put W, I'll just put minus the mass of B times what? Gravity. So equals to what? Equals to 0. In the case the mass is not given. Now rearranging this guy here, I want to eradicate the negative sign, so I'll move them to the other side. So I'm going to be having the mu1 r2 sine theta plus r2 cos theta plus mu2 r1 is equals to P plus the mass of B times what? Gravity. So I'll term this equation 1. Right? Now we've done for along y-axis, so we'll do for that of what? Along x-axis. So I'm going to say that the summation, or let me just put this way, along x-axis. So the forces associated along x-axis, let's start. That means the forces are lying down. So from here, let me start from here. I have u1 r2 cos theta going towards the right. So I'm going to put, first of all, the summation of all the horizontal components, which we call f of x, equals to what? 0. Now we are considering, we want to consider the forward force to be what? Positive, and the backward force to be what? Negative. That is our condition, right? So in doing that, we move forward. We have this facing forward is an horizontal component. It will be mu1 r2 cos theta. So we're having, let's move up, we're having mu1 r2 cos theta, right? And we have another one here again. This is r2 sin theta facing backward, so put minus r2 sin theta, because we said backward force is negative. Now if we move forward again, if we move up, we'll discover that we still have the reaction r1 facing forward. It's perpendicular. So this is 90 degrees. That is why we do not resolve it. So to just be plus r2. So we move there. We have plus r2, right? Then if we move there, we have what else again? It is not r2, it is r1. So let's correct that. So r1, right? That is r1. So if we move forward, we have gotten mu1 r2 cos theta minus r2 sin theta, right? So we have this equals to what? 0. These are the three horizontal forces that we have there. Now we'll make r1 the sort of the formula. I'll call this, first of all, I'll call it here equation 2. So making r1 subject of formula in equation 2, we'll be having we're going to be having, if everything here goes to the other side, our r1 here will be equals to what? Negative mu1 r2 cos theta, because it's crossing the equal sign. This will become plus r2 sin theta, right? Now we've gotten this. I can rearrange it and see that. Just to rearrange, so we have r1 is equals to r2 sin theta minus mu1 r2 cos theta. Now the way it is now, what is common here? I can bring whatever is common out, or I can just decide to leave it this way, right? So now what will I do? I'm going to substitute r1 into equation 1. So substitute r1 into equation 1. So in doing that, I'm going to have, what's my equation 1? This is my equation 1 here. So in this equation that I have here, to make things more easier, I will write it out. So writing it out, I'll be having this. Writing it, this is what I have. So let's start putting our r1. So we have mu1 r2 sin theta plus r2 cos theta plus mu2. So I'm writing r1. I'm going to input the value of r1. So into brackets, we have r2 sin theta minus mu1 r2 cos theta, right? Equals to what? The force plus the mass of the wedge B times gravity. So that is what we have here, right? So in doing that, I will now make r2 the subject. I've done r1, so I'll make r2 the subject. So the only way I can achieve that height is to expand, so that I'll get access to where r2 is, right? So, or better still, I'll bring r2 out here, and I'll take mu inside, or better still, let's move and see. if I bring arrow 2 out, this is arrow 2, right? I have arrow 2 common to everything I have here, right? So I can bring out a bigger bracket, and since arrow 2 is here, arrow 2 is here, arrow 2 is in both sides here, I'm going to bring the arrow 2 out here. So I'll write everything there aside from arrow 2. So this will be mu1 sine theta plus cos theta plus mu2 into bracket sine theta minus mu1 cos theta equals to P plus man BG. So that's what I did. Since I brought arrow 2, so this will be in a bigger bracket. So the arrow 2 here is what we have. Now, we're moving forward. So if I make arrow 2 the subject of the formula here, I will divide both sides by all this. So definitely when I say that, the arrow 2 will now give me a force plus the mass of B times gravity, everything divided by mu1 sine theta plus cos theta plus mu2 into bracket sine theta minus mu1 cos theta, right? So this is what we have in here. All together, we can still move forward if we want to move forward, because in this case here I have I can expand this so that I can bring the cos together, and I can also bring the sine. But since I have sine theta here, I can bring sine theta out here. So let's do that and see. So I'll be having the arrow 2, right, equals to the force plus the mass of B times G, all divided by the mu1 sine theta plus cos theta plus, open the bracket, mu2 sine theta minus mu1 mu2 cos theta. So I expanded this, so I'm having this. Now if I collect like terms here, so let's move forward and see. Now if I collect like terms here, I'll say the arrow 2 will now give me the force plus the mass of B times gravity all over. Now watch, bring all the sign together. I have mu1 sine theta, and I have another sign here plus mu2 sine theta, right, plus cos theta minus mu1 mu2 cos theta. So I brought them out. So if what is common to this side, sine theta. So I'm going to say that the arrow 2 will now give me the force plus the mass of B times G all over what is common here, sine theta. So if I bring this sine theta out, I'll be left with what? Mu1 plus what? Mu2, right? Plus we have cos theta. If I bring the cos theta out here, I'll be having what? 1 minus what? Mu1 mu2. So because this is only cos here, the question that's remaining here is just 1. So this is what we have for my arrow 2, right? So we move forward. So moving forward, we'll go to the other wedge, which is wedge B, wedge A. So we'll just do wedge A. So if you look at our question here, we have this. So we want to draw this out back. So we're going to draw the free body diagram of this. So let's do that first and see. So in drawing that out, we are going to be having this. So we want to start. Now the key word here is all the contacting surface will have a reaction, right? So since we said that from here that we said the first contacting between the guide is arrow 1, right? The other one here is arrow 2. So since I have this to be arrow 2 and my weight is acting downward. So since weight is acting downward, it will be acting straight downward on this guy this way. just this way. That will be coming this way. That is the weight there, right? So in doing that, I'll call this to be the W, which is given as what? M mass of A times what? Times G. Is that okay? Now, in doing that, we have what is called the reaction. From here, since I have the reaction of R2 going up, the other reaction will still be R2, it will be coming down, because to every action there's equal and opposite reaction. So the R2, this R2 will now be on this surface perpendicular to it this way, right? So I would like to draw it this way. So I'll put it the arrow here. So I'll term it the R2. That is the line of what? R2. So it will still be R2 because this is the contacting surface 2. Now another contact surface that we have is here. At this point, we'll call it R3. That will be R3. Right? Now the thing we need to understand is from our diagram here, since there's a reaction mu1 R2 going this direction, the other one will be coming opposite direction. So let me just put it here, coming opposite direction this way. So this will be still your mu1 R2. Still the same thing, right? Because as this, you are pushing this down, as this guy is going forward, this will be going backward, and when it's going backward, the direction will be coming forward. That's why this guy is what? Forward. So let me try and extend it out to this edge here. Sorry, let me extend it. So I know why I'm extending it there. Now the next thing we'll be doing will be, this will be moving forward too. Is it forward or backward? It will be going backward, because when I push this down, right, this will be going backward this way, while the reaction force will be coming forward, right? So we're having one coming in this direction. So that will be my F3, right? So F3, we know that from what we did, analysis we did here earlier, it says our F3 now will now be equals to, now what did I tell you? This part here is the contacting surface. Here and here are contacting surface. So the contacting surface we are using is mu1, right? So in this case, I'm saying my F3 will give me mu1, but what? R3, because this is the reaction 3 here. So I'll say this will give me what? mu1 R3 going in direction. Is that okay? So in doing that, this is what we have, right? So we are going to start resolving. So in resolving, first of all, resolve this. I will draw an arc coming this way, as in a line coming straight down this way, right? So this is what we have here, and I have another one coming in this direction here. This is what we have here, right? This will be going in this direction. Now what do you notice? If you look at it, it is inclined to what? To the vertical, right? So we'll be having this to be R2, right? R2 sine theta. So also the angle theta, because if you look here, what we have here, our R2 here, the vertical is cos, the horizontal is sine. Simply the same thing here. Horizontal is sine, vertical is cos, but direction changes, right? So we have R2 cos theta to R2 cos theta. Now putting them in the bracket sign so we'll know what we'll be using. We'll be using this one too. And also we're going to be using this guy too here, right? This is the weight acting straight downward. Now this is also inclined. We're going to resolve it. So in resolving it, it will be this coming up this way. Just a little bit extended up so we know what we're dealing with. So we're having the vertical line, this coming up this way, right? And this coming this way also. A better still, we do it this way. This coming here, and this coming here. So we have a reaction at this direction, and this at this direction. So what you notice, it is inclined to the horizontal. Can you see that? So whatever we have, this will be mu1 r2, here also mu1 r2. So since it's inclined to the horizontal, this will be cos, and this will be what? Sine. Is that okay? Sine theta and what? Cos theta. So we successfully drawn out all the reaction. Are we good? We are still working against this guy here. This is still theta here that we are working with. So now let's do the same thing we did for the initial one. We need to write all the forces by using the condition for equilibrium. So the first condition for equilibrium that we have here is that along y-axis, right, we have the summation of what? Of f of y equals to what? 0, where we want to consider the upward force to be what? Positive, and the downward force to be what? Negative, right? So if you look at this, r3 is an upward force, so I'll put r3, right? Then what else again do we have? So we have the weight is acting downwards to be minus, I'll put w, I'll put what? The mass of A times G, which is gravity, right? This is also acting downward, that will be minus r2 cos theta, right? This is also acting downward, that will give me minus mu 1 r2 sine theta. So that's all we have there. So equals to what? 0, right? So from here, if I take them to this side, my r3, the r3 will be equals to the mass of A times gravity minus plus r2 cos theta plus mu1 r2 sine theta. This will have. So I'm going to term it equation what? Equation 3. If I want to term it equation 3. How good? Or better still, I'm going to term it maybe equation 4, equation 5, depends on you. So this is what? Equation 3. I should still term this. Here we have, let me call it, this will be equation 4, this should be equation 3, and this will be what? Equation 4. So let's just do that, depending on you. So let's move forward. Now we've gotten R3. Now the next thing we are going to be doing here is that we are going to doing the summation of, let me just put it this way, along x-axis, right? So it means the summation, the equilibrium of forces of the horizontal component is equal to 0, and we want to consider the forward force to be positive and the backward force to be what? Negative, right? So if we do that, we look at our diagram very well, we realize that this is coming down. Since it's parallel, we don't have to resolve it, so we're making use of this guy also. So that is what? Mu1 r3, and it's going backwards is negative, so we have minus mu1 r3, right? We have this here coming backward, that is negative also. We have mu1 r2 cos what? Cos theta. Cos theta, right? So we have another one again coming towards the right, and that is what? r2 sine theta. So we have this to be r2 plus r2 sine theta equals to what? 0, right? So in this case, you can make r3 instead of the formula. You can put your r3 into this, right? So that's, I'm going to tag this equation what? Equation 5, right? So from this equation 5, you can make r3 the size of the formula. So making r3 the formula in equation 5 here. So make r3 the what? The subject. Right? So this will give us from here, let's see, I'll take all this to this side. So I'll be left with, or better still, because this has a negative, so I will take both to this side, right? So I'm going to be having, minus mu1 r2 cos theta plus r2 sine theta equals to, see this guy, I take it to this side, so it will become mu1 r3. mu1 r what? r3. So if I divide both sides by mu1, so we'll be having r3 is equals to, if I arrange this, it will give me the r2 sine theta will come first, minus the mu1 r2 cos theta, right? All over what? mu1. So it is mu1 right there. Is that taken? So in doing that, we've gotten r3. Now you substitute it into equation 4. So substituting into equation 4, substituting into equation 4, right? We'll be having this equation 4, so we'll put our r3 there, so we'll be having this. So anyway I say r3, I'll put this there. So I'll write this first. I have written this in place of r3 in equation 4. So equals to, we have the mass of A times gravity plus the r2 cos theta plus the mu1 r2 sine theta. So this is what we have. Now from here, we are going to, if I cross multiply from here, I'll be having r2 sine theta minus mu1 r2 cos theta is equals to, if I open the bracket, mu1 times this will give you mu1 mag plus mu1 times this will give you mu1 r2 cos theta plus mu1 times will give you mu1 r2 sine theta, right? So in doing that, this is what we have here. So now you collect like terms from this given equation here. So in doing that, bring everything that has r2 to one side, right? So I'll be having the r2 sine theta, right? And this is minus mu1 r2 sine theta, because when it's coming here, this corresponds to minus, right? To the next one, minus mu1 r2 cos theta, which is this. And when this comes here, it turns to minus mu1 r2 cos theta, right? Equals to this guy here, which is what? mu1, right? The mass of wedge A times gravity. Now if you look at all this through, R2 is common. So if I should write out my R2, I put in my brackets, I'm going to be left with what? Sine theta, right, minus mu1 square, because mu1 will give mu1 square. So we have sine theta minus mu1 cos theta minus mu1 cos theta equals to mu1 mass of wedge A times gravity. So I brought the R2 out. Now if I choose to write this, right, I can factorize, still having R2 open bracket. What is common here? Sine theta is common. I bring out the sine theta, open the bracket, here will remain 1 minus what? Mu1 square, right? Then I have what's common, this is minus minus. If I bring the minus out, I'll be left with cos theta into bracket mu1 plus mu1, because minus cos theta times mu1 will give you minus mu1 cos theta, minus cos theta times mu1 will give you minus mu1 cos theta. So we're having this equals to what? Mu MAG. So from here we can keep moving from here, and we'll have this way. So we'll have this way. So let's move. So from this aspect here, if you divide both sides by this, you'll be having R2 is equals to the mu1, right, of the mass of wedge A times gravity, everything divided by sine theta bracket 1 minus mu1 square, that again mu1 square, close the bracket, minus cos theta into bracket mu1, that I'll call it 2 mu1, because mu1 plus mu will give you 2 mu1. So this is what we're having here, right? So now I'll be sticking with this, right? Now I've gotten R2, so I will call it equation, I'll call it equation 7. Let me call it equation 7. Equation what? 7. Now from here, from this equation here, I'm having R2 equation 7, and what we did earlier at the beginning, we still have R2 again. You can recall, you check equation, we have in the beginning here that what? R2 is given as what? P plus the mass of B times gravity over what? Mu1 sin theta plus cos theta plus mu2 sin theta minus mu1 cos theta. Or if you don't use this, you can come to equation 5, where R2 is given as this. So a continuation of this, our equation 5 here, it says that our R2 is given as what? This over this. Either I use this or the other one, but you can use this. This is the simplified form of the other one. So this is R2. So you equate R2 of this to the other one, right? And this is what I mean here. So if I do that, if I now want to rewrite, I'll say the R2 from equation 5 above, so it will give us, substituting, you write substituting R2 from equation 5 above into equation what? 7, right? Into equation 7. So we'll be having, what is the R2? The R2 is given us the force plus the mass of wedge B times gravity all over sine theta bracket mu1 plus mu2, we close the bracket, plus cos theta bracket 1 minus mu1 mu2, right, equals to this. This R2 is this, then equals to this, and this is what? Mu1 mass of wedge A times gravity all over sine theta bracket 1 minus mu1 square minus 2 mu1 cos theta, right? I rearrange this back. This is what we're having here. So we work with this. Now we will cross multiply, right? So by cross multiplying, or we input the values of it. So let's try putting our value of it and see what we are going to get. We know very well from our parameter the force P is given as what? 350 plus the mass of B, which is what? 25 times gravity, we say it is 10, right? All divided by the sine of theta, open bracket, mu1 is 0.25 plus mu2 is 0.15, we close the bracket, plus cos theta into bracket 1 minus, we have mu1 which is 0.25 times 0.15. So this is what we have here, equals to, from here we have mu1 which is giving us 0.25 times the mass of A, which is 320, times gravity, which is what? 10, all over, we have the sine theta bracket 1 minus mu1 is 0.25, but there's a square, close the bracket, minus 2, mu1 is 0.25, right, cos theta. So we have what? Cos theta here. So in doing that, if you multiply all these together, you are going to be having, this will give me 250, 350 plus 250 will give us what? 600. So this will be 600 all over. Now we have sine theta in bracket 0.25 plus 0.15 will give me 0.4, right, plus cos theta into bracket 1 minus 0.25 times 0.15, that's going to give us 0.0375, 0.0375, right? Now we have this after inputting our value, so equals to, now equals to 0.25 times 320 times 10 is going to give us 800. So this will give us 800 all over, we have sine theta into bracket 1 minus 0.25 square is going to give us 0.0625, 0.0625, we close the bracket, then minus 2 times 0.25, 2 times 0.25, that will give us 0.5, so we have 0.5 cos theta, right? So this is what we have. Now the next thing, if I move forward, I'm going to have 0.4 sine theta, sorry, I'm going to have 600, right, all over 0.4 sine theta I rearrange it to this onto the front, plus 1 minus 0.35, 0.625 is going, 1 minus 0.075 will give us what? That is going to give us 0.9625 cos theta. I will arrange that, right? So equals to 800 all over 1 minus 0.0625 will give you 0.9375. So this will give us 0.9375, right? So sine theta, I took it to the front, sine theta minus 0.5 cos theta. Now in doing that, so the next thing we should be doing here is we are cross multiplying. So if I cross multiply, here will give us 600 open bracket 0.9375 sine theta minus 0.5 cos theta is equals to 800 bracket, this is coming up to 0.4 sine theta plus 0.9625 cos theta, right? I close the bracket up. So from here, if I expand, if I multiply 0.9375, 0.9375, right, multiply by 600, I'm going to be having 562.5. So this will give me 562.5 sine theta minus 0.5 times 600 give us what? 300 cos theta equals to 800 times 0.4, and that will give us 320 sine theta, 320 sine theta plus 800 times 0.9625, that will give us 770 cos theta, 770 cos theta. Now I'll collect like terms, bring all the sine and all the cos to one side. So I can say that 562.5 sine theta, right, minus 320 sine theta, because when it's coming become negative, is equals to 770 cos theta, right, plus 300 cos theta. So this will now give us 562.5 minus 320, and that will give us, going to give us 242.5. So this will give us 242.5, right, equals to 242.5 sine theta, right, equals to 770 plus 300 will give us 1070 cos theta, right? So from here, if I divide both sides by 242.5, I will have sine theta, this is 242.5 over 242.5 is equals to 1070 cos theta over what? 242.5, right? So this will equal this. So we are going to be having sine theta equals to 1070 divided by 242.5, and that will give us 4.412 cos theta, right? Now I'll divide both sides by cos theta, so I'll have this over cos theta all over this over cos theta. So cos theta will create cos theta, so we're going to be having both sine theta over cos theta is equal to what? tan theta, right? That is the trig identity there. So we'll now see that the tan theta will now give us 4.412. So if I take the theta to the other side, so theta will now give me tan inverse 4.412. So theta will now give me 77.23. So I'm having 77.23 degrees. That's our theta, right? So if I want to get my theta 1 prime, theta 1 degree is going to give us 90 minus theta, right? So this will now give us 90 minus 77.23. So that will give us 12.76. So my theta 1 will give us what? 12.77 so degree. So this is my theta 1. We'll go to the next aspect, which is the next category of the question. Look at the top right corner of the screen. It says that we should determine the value of theta 1 degree if the required effort is this. Then the other part of the question is, what will be the value of theta degree if P is 450 Newton and the coefficient of friction between all contacting surfaces is constant and equals to what? 0.2. So it means that mu1 and mu2 are 0.2. That was telling us. So it said we should estimate also the value of R1, R2 and R3. So what you simply do here is that we know that our R2 is giving us R2 here. You know, R2 is giving us what? We have 2 R2, right? So R2 from this equation here. So from this equation we used earlier, where we equated R2 equals to this, right? Equation 7 here. Now we later place our R2 to be equals to this 2 here. The first R2 is P plus mass of B times G over all this, and the second one is this, right, which is this one here. So in this case we're not going to use our mu to be 0.25 or 0.15. In the question is that we should use the mu should be uniform, equal, and that should be what? 0.2. So we are going to use 0.2 throughout of the mu, but now we'll not change our force to be what? 450 according to the equation. So I'm going to rewrite this equation here and I'll start inputting my value, and let's see. So this is what we're having, right? So what you need to know is we are told that mu1 is equals to mu2 is equals to what? Mu is equals to what? 0.2, and the force P is equals to what? 450. So we are going to input these values here. So inputting those values, I'm going to be having this. So that's what we have here. So anywhere I see mu, whether it is mu1 or mu2, I'm going to put 0.2. So in doing that, 25 times 10 is 250 plus 450. That is going to give us 700, right? So this will give me 700 all over sine theta. Now 0.2 plus 0.2 will give me 0.4 plus cos theta into bracket 0.2 square is, so that will give us 0.04. So we have 1 minus 0.04 equals to, if you multiply all this, 3200 times 0.2, that will give us 640. So we have 640 all over sine theta into bracket, we have 1 minus 0.04 minus 0.4 cos theta. So in this case we move forward. So this will be 700 all over 0.4 sine theta plus 1 minus 0.04 give me 0.96 cos theta equals to 640 all over sine theta. 1 minus 0.04 will be 0.96, right, minus 0.4 cos theta. So if I cross multiply here, this will come up here and this will come here, so we'll be having this, right? So if you multiply 700 times 0.96, we'll be having 672 sine theta minus 700 times 0.4, that will give us 280. So we have 280 cos theta is equals to 640 times 0.4, so that will give us 256 sine theta plus 640 times 0.96, so that will give us 614.4 cos theta, right? So this is what we have here. So collect like terms. So we're having 2672 sine theta, this is coming here, minus 256 sine theta is equals to 614.4 cos theta plus 280 cos theta, right? So we'll be having, when you add 272 and 256, since they are like terms, I'm going to be having 416 sine theta equals to 614.4 minus 280, we'll be having 334.4 cos theta. So you're adding them. When you add them, you have, sorry, it's 894.4 cos theta. By the time you do your normal mathematics here, this 416 will come here, so we have sine theta over what? Cos theta is equals to 894.4 over what? 416. So the long run divided by 416, we'll be having this will give us 2.15, and sine theta over cos theta is what? Tan theta. So from here we can say that tan inverse theta is equals to what? Tan inverse 2.15. So if you do that, we're having 65.06. So theta will give us what? 65.06 degree. That will be the value of what? Of theta.